I usually start my videos with a white screen because I think it helps you to see me writing things out in real time, just as if I was writing on a whiteboard at school. But this time I wanted to write all these out so it was easy to see. And I want to ask you uh, what might be an interesting question. My question is, of these, let's see, 1, 2, 3, 4 by 1, 2, 3, 4 times 3, 12 expressions. How many of them are equivalent to this first expression? Right? If I have this expression and calculate it and get the answer, of the remaining 11, how many will give me the same answer? Take a minute, write these down, think it through, and just try to figure out what the answers are to all of these. Well, if you guessed 7, you're correct, because all of these on the outside columns are really the same problem. Right? If we understand what our operations are, their true definitions and how they relate to each other, this shouldn't be an issue. This is saying 3 plus 5 sevens. 3 plus 7, 2, 3, 4, 5. 5 sevens. 5 sevens is 35, so that's 3 plus 35. That gets you 38. This is saying 3 plus 7 fives. Well, 7 fives is the same as 5 sevens. Multiplication is commutative. So 35 and 35, 3 more than that, 38. Right? If I had done the 5 times 7 first, then add 3, I'm still doing 35 plus 3 to get 38. In fact, I think this is probably the easiest problem. If you start at 3 and you have to count 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, there's 10, 14, 15, 16. Counting up by 35 is a lot. That's hard. But by using the commutative property, we can start at 35 and then add 3. 35 plus 3, 36, 37, 38. That I can do very quickly in my head. I don't have to use my fingers. 35 plus 3. Same thing here. 7 times 5, same as 5 times 7, 38. These parentheses around the multiplication aren't changing the problem. Multiplication is repeated addition. So if I write that out the long way and I have only addition, I could have gone 7 plus 3 is 10, 10 plus 7 is 17, 17 plus 7 is 24, 24 plus 7 is 31, 31 plus 7 is 38. But those plus 7s I had to think a little bit harder than if I had just added up all the 7s first instead of starting at 10 where I'm not used to starting with my multiples of 7. Right? This isn't changing anything. I'm going to add up all those 7s first, get 35, then to the 3 to get 38. We don't put parentheses around multiplication because by the definition of multiplication, we're doing that before we add. By putting parentheses around this addition, that's changing the problem. This isn't saying I have 7 fives. This is saying I have 7 3 plus 5s. Let me change color here. 3 plus 5, and another 3 plus 5, and another 3 plus 5. Should have used a smaller number. There we go. Well, 3 plus 5 is 8, so instead of adding up 7 3s and adding up 7 5s, I might as well just add up 7 8s. 5 plus 3 is 8. 8 times 7, not 48. That's 8 times 6. 8 times 7, 56. Or I could say 7 3s is 21. 7 5s is 35. 5 plus 1 is 6. 3 plus 2 is 5, right? The distributive property doesn't get us the wrong answer. It's just unnecessary here. I might as well just add in the parentheses first. Now this is a fundamentally different problem. I don't have 7 3s and 7 5s. I have 7 5s and 3 5s, or 5 7s and 5 3s. 7 plus 3 is 10. 10 plus 5 is 50. That's a completely new number. Here, 5 7s. I had 5 7s last time. 5 3s. I had 5 3s last time. This is still 5 times 10. I just used the commutative property of multiplication to put this 5 over on the left. So this one is also 50. Here I have 7 5 plus 3s. Well, that's the commutative property of what I started with first, but I'm using the commutative property of multiplication to put that 7 as the first factor, and the 3 plus 5 as the second factor, and also the commutative property of addition, where instead of 3 plus 5, I change the order of those two inputs to be 5 plus 3. But it's still 5 times 8 to get 56. Right? We can use the commutative and associative properties to recognize that these two are the same problem, but that these two are the same problem as each other, but different from these outer ones. We have to recognize what's being multiplied by what's being added a bunch of times, what's only being added one time, and where those grouping symbols come into play. Okay, let's turn to another set of expressions. And I'd like you to calculate all 8 of these and then tell me how many different answers are there. Are there 8 different answers? Do all 8 give you just one answer over and over again? Tell me how many different answers there are. Okay, well, instead of just having the answers pop up here, I want us to walk through these together first. What's different about all of these 8? I hope you're seeing the parentheses here, right? Whether I use parentheses or brackets, those grouping symbols might be changing the expression dramatically. Now there's another difference between the left column and the right column, and that's the dot here, right? Sometimes I have a dot between the 3 and the 5, sometimes I don't. So the question is, how relevant is that in how to handle the problem? Well, this one's probably the most straightforward. A 3 next to a 5 means a 2-digit number, 35. So I have 2 positive minus 35, that's negative. 6 is positive. So I'm going to say the 2 and the 6 are both positive, that's 8. 8 forward, 35 backwards. Those are going in opposite directions, so I'm going to do the difference. 35, borrow here, 15 minus 8 is 7. I borrowed here, so that becomes 27. So I get 27. But I was going a lot farther negative than positive, so my answer is negative 27. This problem is doing a similar thing, but instead of 30 plus 5, it's 3 5s. I have 2 moving forward. I have 3 5s all in the backwards direction. 3 5s is 15. So I'm backing up 15. And then going forward 6. I still have 3 terms here. So just that this middle term includes multiplication that I have to calculate. 3 times 5 is 15. Now 6 plus 2 is 8. 8 minus 15, I kind of already did that here. 15 minus 8 is 7. So I get 7, but in the negative direction. Okay, 2 different answers so far. Now, moving down here, I don't have 3 separate terms. This plus is separating the 6 from the 5, but the 5 isn't a term by itself. The 5 is telling me how many of these 2 minus 1s I have. This is all one term. I don't know what direction that term is until I've carried out the multiplication. So to carry out the multiplication, I have to do 5 times this thing. Well, this thing I can actually do. 2 minus 3 is negative 1. And then negative 1 times 5 gives me negative 5. And then that negative 5 plus 6, now I can combine my terms. Negative 5 plus 6 is positive 1. Now I could say positive 1, but that gets a little silly since most of the time our numbers are positive, right? I'm not putting a positive in front of the 2 here. That's just kind of distracting. So if I look at this version, a closed parentheses next to the 5 also means multiplication. These two are really the same problem, right? And these two are the same problem, and these two are the same problem. When we have a parenthesis next to another parenthesis, that means times. When we have a parenthesis next to a number, that means times. But when I just have two numbers next to each other, that doesn't mean times, that means a 2-digit number. Right? So we just have to recognize that syntax of how symbolic algebra works. So if I already calculated this one, I know this one is also 1. Let's go back to my green. Here, I'm not adding 6 as its own term. 6 is within these parentheses. The 6 and the 5 are being added. 6 plus 5 is 11. And then I have 3 11s. 3 11s is 33. And then all of that is being taken away from the 2. The 2 is a term by itself moving forward. This whole thing is a second term. It looks like it's moving backward. Once I've done the calculation, I get a positive number. So I'm reversing the positive number. It is going backwards. 33 minus 2 is 31. So 2 minus 33 will be negative 31, which means this is also negative 31. All right, here 6 is not a term by itself. It's inside the parentheses with the 5. So I'm doing that operation. 6 plus 5 is 11 times 3. No, the 3 is in parentheses. The 3 is being subtracted from the 2. 2 minus 3 is negative 1. Now that I've done what's inside the parentheses, I can do the multiplication. Negative 1 times 11, negative 11. And since this is the same problem, negative 11. So we have 1, 2, 3, 4, 5 different answers here, even though the problem looks very similar in all 8 versions. Okay, let's go to one more problem where we're dealing with the order of operations with just numbers here. All right. So complicated. I've got minuses and times and pluses and 2 different grouping symbols. This can be intimidating, right? Even if you've made it through algebra pretty strongly, we can still look at these and feel overwhelmed, especially if we're still trapped in that old left to right mentality, right? To simplify these expressions, to simplify any expression in mathematics, there are 2 steps we have to follow. First, simplify each term independently. I don't know why I capitalized the E. Simplify each term independently. Second, combine terms, like terms, because not every term can be combined. And that's it. Right? Now, technically, I should say step 0, identify the terms, right? Some problems are really just one big term. They're multiplication problems or division problems. But this will work out within the grouped operations as well. So let's start with step 0. We're not actually calculating anything, but it's a necessary prerequisite step. And to get my colors the way I want them here. Okay. So right now, how does this problem start? 2 minus. That's a term. That's a term moving forward. It's a positive 2. Minus means I'm adding the opposite of whatever comes next. The opposite of 6 times 14 times, that means I'm going to be doing multiplication. That's not an addition problem. 6 is not being added to anything. 6 is being added to itself 14 times. And then I'm adding new things. So all of this is one term. Then plus 3, but I'm not just adding 3, I'm adding 3 of these. So all of this is one term. Then I have another minus 2. That means add the opposite of 2, but it's not just 2, it's 2 of this bracket. All of this is one term. So I really have 1, 2, 3, 4 terms. There's my first step taken care of. Now, actually doing the math, simplifying each term independently. 2, there's nothing to simplify there. 2 is 2. 6 times 14, I can do that off to the side. 6 times 4 is 24. 6 plus 2 is 8, so that's 84. Make my 8 look like an 8. In the negative direction. So whether I write minus or plus negative, I'm recognizing that's forward, that's backward. Plus. Now to simplify this term, I've got a few things to do here. Right? Notice I'm not doing 2 minus 84 yet. I've simplified this term. Now I'm moving on to this term. I could distribute. 3 times 8 is 24. 3 times 6 is 18. But it's a lot easier to just say, well, in order to multiply, I'm multiplying by this. 8 minus 6 is 2. So there's 3 times 2. I know what 3 times 2 is. It's 6. Right? So this term has a value of negative 84. This term has a value of 2. This term has a value of 6, meaning positive 6. That brings me to my last term here. There's a lot going on here. So before I start doing 2 times 5, I'm going to have 2 times this big mess. Why don't I just calculate what's in here first, right? The parentheses are telling me do these operations first, then take that value, subtract it from 5. So inside the parentheses, I have 2 terms within these parentheses. So simplify this term first. 4 times 7 is 28. 28 plus 3 is 29, 30, 31. So this is really showing me 5 minus 31. Right, I've performed the operations inside the parentheses first. Now that has taken me to the brackets. I want to perform these operations, this operation of subtraction before I multiply. 5 minus 31, well that's really 31 minus 5, but the opposite of that. Right? So 31 minus 5, that's 26. So that's negative 26. So 2 times negative 26. Double that, you get 52. Negative. But there was a minus sitting out front here. I really have 2 minus 84 plus 6 minus, that's this minus. This gave me negative 52. So I'm subtracting a negative 52. We're adding the opposite of negative 52, right? This little blue negative is being applied to the negative 52 I got from these calculations. The opposite of negative is positive. Now I've simplified each term, right? Not by going left to right. I looked at each term left to right. I could have gotten the 52 first, then come back and looked at the 6. But the last thing we're going to do is our addition and subtraction, unless there was addition or subtraction inside grouping symbols that's part of some larger term, right? But for the big picture here, combine like terms, let's see, the 6 and the 2 and the 52 are all going forwards. There's no quick canceling positive negative of the same value. So I'm going to say 52, 53, 54. 4 and 6 is 10, so 54 plus 6, that's 60. 60 all to the right, 84 to the left. That leaves 24 to the left, right? 80 minus 60 is 20. So 84 minus 60 is 24, but it's 24 to the left. So my final answer is negative 24. Right? And you can get all kinds of varieties of expressions with grouping symbols or without grouping symbols. If we follow these 2 steps with the kind of extra step out front, these 3 steps, every expression without variables should be just as easy for you. Some might take longer, some might take more concentration, but we're going to be fine with all of those. Now we'll look at some problems with variables.